Remember the first time you really got a handle on branching in Git? You thought, this changes everything. Well, Iceberg does that for your data. Every table has a main branch, and every time you modify the table, it creates a new snapshot, and that branch reference, main, follows along with the new snapshot. So that label, that reference, is always pointing to the new snapshot that you make. You don't do anything to advance that. You don't even need to think about it all the time. It's just happening under the covers. Our good old sales table has a main branch, and it's running in production, serving dashboards and reports across the company. But then somebody calls. They say, bad news, widget B was mispriced. Should have been 10% cheaper. They need you to fix it and estimate the refund impact. But you can't just start updating production data. Those calculations need testing, and finance needs to approve before we do it. This is just kind of a let's project what the impact is going to be sort of thing. Get it wrong, you've got broken revenue reports, angry customers, probably angry executives. Nobody's having a good day. With Iceberg, it's simple. We're going to create a pricing fix branch to do all of our work. So you do that, you test your calculations and your updates, get validation from finance that everything looks right. And it's okay if you break things, because main will stay untouched until you're confident that everything looks good. And main, there could be new sales posting, new commits happening there. That's fine. You're off in, as it were, your own private Idaho in your pricing fix branch. Once finance approves of your refund calculations, you update all of the widget B sales on your branch with the revised amount. This creates a new snapshot, right? I mean, you've written stuff, you've done some updates, so we get a new snapshot. We're going to call it snapshot 3 for simplicity. Now, real snapshot IDs are big, long, random-looking numbers. I'm using 1, 2, and 3 because we like them to fit on the slides. You just need to know that they're not necessarily sequential in real life. Time to verify the fix. Branch query syntax is another one of those things that's engine-specific. With mine, I'm simply appending .branch_pricing fix to the table name. Check the docs for yours, could be something different. Widget B was $200 in main. With 10% off, we should see $180, and we do this query. There it is. That looks good. Looks like the update we did was basically sane and did the right thing. But again, this update has no impact on main. That's not where the snapshot is written. Production keeps running, doing its thing. New sales are posted. New snapshots are created. Business as usual. Okay, you've been working on your branch. Finance has approved everything. Time to merge it back to main. Iceberg's fast forward procedure, which you can see in this call here, handles this operation. Let's run it. Oh, we got an error message. What happened? Fast forward works like a Git fast forward. It requires main to be a direct ancestor of your branch with no additional commits or snapshots on main. But here, main has moved forward. New changes landed while you were working, which is kind of what we'd expect, right? Fast forward is a great case, just like merging in Git. It's always like, well, you know it's going to work. It's super trivial. It's just moving pointers around. But it's not terribly difficult to imagine that production moves forward while we're off doing our testing. So now what? Well, because you used update operations, you can't fast forward. The only option here is to start over. So what we're going to do is drop our pricing fix branch. We're going to recreate from the now current main, rerun the update. Now main is a direct ancestor, and now fast forward works. Main can advance to snapshot 6, matching the new pricing fix branch. Fast forward is the simplest way to merge changes. It moves your branch pointer forward, and that's it. No new snapshot, zero overhead, really just a change in what Iceberg calls a ref, or a reference. But we saw that catch. It only works if the target branch is a direct ancestor. If histories have diverged, fast forward fails. Kind of a bummer. So what should you do when fast forward won't work? Use cherry pick. Now, again, there's a direct analogy with Git, and cherry pick tends to be kind of an advanced Git feature. You may not know how to use it. If you do, just kind of take all that understanding you've got, bring it to the party right here. It's going to help a lot. If not, let's just work through this diagram together. So you've built this new ETL job for partner sales on this new sales branch, adding 1 million records. That branch is split from main at snapshot 5, creating snapshot 7. But main keeps moving. Life goes on without us, right? It's now at snapshot 6. Histories have diverged. We can't fast forward anymore. Cherry pick to the rescue. So take snapshot 7. This is what cherry pick means. Take snapshot 7, replay it on top of the current main branch, and that will create snapshot 8 that's got snapshot 6 plus snapshot 7, all that content in one place, at least hopefully. And we do that by calling the cherry pick function, as you can see here. When histories diverge and fast forward fails, cherry pick is your solution. It takes a snapshot from your branch and replays those changes on top of the current main state, creating a brand new snapshot with everything combined, with 2 important limitations that you should know about. First, it only works with append operations and dynamic overwrites. No row-level updates can be allowed when you're cherry picking. So if you've got snapshots with row-level updates in them, cherry pick's not going to work. Just append and dynamic overwrite. Second, cherry pick only integrates changes into main, not other branches. Kind of a strange limitation, but you're not allowed to cherry pick, say, from main into your branch or somebody else's branch into your branch. It really is designed for bringing main up to date, for bringing work from a branch into production. That's branches. Let's look at tags. And again, with Git, they're just exactly the same. A tag is an immutable, friendly label that points to a snapshot. So say snapshot 2 is special. And remember, in the real world, a snapshot ID is a terribly unfriendly number. You're only ever going to copy and paste it. You're not just going to keep it in your head. So maybe it's quarter end data, or it's what you presented to the board, or exact state auditors will ask about 6 months from now, something like that. Whatever the reason, you want to preserve that specific point in time. So you create a tag for it. In this case, Q3 report. One alter table create tag command, and you're done. That's it. That label is assigned to that snapshot, and it'll be there for as long as you'd like it to be. And you can query a tag with the tag underscore syntax. Another one of those things could be engine dependent, so check your docs. But this shows the sales table as it looked, as it existed at the time of the Q3 report tag, right after the second insert you see here. What if you're curious about the branches and tags that are extant for a particular table? You've got this metadata table called refs that kind of hangs off your main table. And so in this case, we would query sales.refs, and we'd see these are our branches and our tags. This is a table you just get to read. Iceberg keeps it up to date for you. Every branch, every tag, they're all there in one place. Hopefully these aren't getting totally out of control with lots and lots of branches. You could imagine projects in Git where there are many branches that live a long time. I don't know if that we always want to see that in our data lake, but it's a valuable, important feature that you should make use of. Likewise, tagging, that's a thing. You might end up with lots of tags. And so it's nice to be able to list those and see them all in one place. And remember, these are separate things, branches and tags. It's not like you pick one or the other. They're both tools that you should have in your toolbox. A branch is a mutable line of table evolution. It's a name for an alternate history that you get to evolve. It tracks its own chain of snapshots as you write your data moving forward independently. It's exactly like Git branches. Use them for experimentation. You can create dev, staging, QA, kind of environment branches for testing changes without affecting production if you don't have literally a whole separate dev or staging data lake. Main is always the default branch. Every table has one. Reading or writing to main, you don't have to say anything about a branch name. That's where you're going to be. By default, that's the branch that any query is going to read or write. For other branches, you do need to reference them explicitly like you see here. Tags are different. They are immutable pointers to specific snapshots. Tag a snapshot, stays there forever. It's like a bookmark that doesn't move. Doesn't matter what new snapshots you create, the tag just stays there. Use that to mark important snapshots that you don't want to lose, that you want to be able to refer to by a human readable friendly name. You know how I mentioned a minute ago that if you just had branches proliferating like crazy, that could get a little messy? Well, yes, every snapshot adds metadata. If you kept every snapshot forever, that metadata just keeps growing without bound. Usually, you only need fairly recent history, a month, a quarter, whatever the lawyers tell you. Maybe not 10 years of snapshots. Iceberg gives you built-in retention policies for branches and tags. So you can set retention rules, and old snapshots associated with those branches and tags can get cleaned up automatically. When you're creating a branch, you get to set two things: how long the branch lives and how much snapshot history you want to keep. So here we're telling Iceberg two things. We're saying pricing fix, the branch pricing fix, we want that to live for 7 days. Even if it sits idle, just let it sit there, but hold on to only the last 2 snapshots in that branch. So 7 days pass with no writes, branch gets dropped, it's out. More than 2 snapshots accumulate, old ones get cleaned up automatically. That's pretty aggressive, I think, 2 snapshots. But for illustration purposes, there you go. You get to set a snapshot retention period within the branch. And continuing the Git analogy, this is very much unlike Git, where cleaning up an old commit, getting rid of an old commit is inconceivable, right? It always has to keep the whole history, and that whole graph is always there in the repository. Not the case here. We're not going to retain data indefinitely. There are definitely lawyers who are going to get mad at you try to do that. So we have tools in our toolbox for setting those retention periods. Tags, again, great for preserving important things, quarter end data, checkpoints, all that kind of stuff. But even critical snapshots don't need to live forever. Weekly tags from last year, nobody is looking at those. Even quarterly snapshots can expire after a reasonable period. This command that you see here creates a Q3 report tag on snapshot 2 and tells Iceberg to keep this snapshot alive for 365 days, regardless of other cleanup operations. So the tag gets this year-long life. That snapshot gets a year-long life with it. So while newer snapshots on main could get cleaned up sooner, depending on other retention policies, snapshot 2 stays locked down for a year because of this tag. If you're a data engineer, you're probably familiar with the Write-Audit-Publish pattern. If not, it's a 3-step approach to prevent bad data from being ingested by users and other systems, from it becoming visible in production. The idea is simple. You write new data to an isolated environment that nobody else can see yet, just you. Maybe it's great data, it's the best data, it's very classy data, but maybe it's garbage. It doesn't matter because it's not in production. Then you run your validation suite. Check for nulls where there shouldn't be nulls, look for duplicates, verify schema integrity, do all your cleanup stuff. This is 90% of your life, you know. And this is your chance to catch problems before anybody else sees them. Only after validation passes do you commit to production. The switch is atomic. Old data one moment, new data the next. There's no partial updates. This process really shines when things go wrong. Like if validation fails, just discard that branch and try again. No rollback complexity, no production corruption, no explaining to your VP why revenue suddenly went negative on the dashboard. Iceberg has this mode built in, which makes this pattern easy. First, enable it and give your session a branch name. Any identifier works. Here we have ETL run 2025-10-30. You see that there on the 4th line. From now on, every write, that's insert, update, delete, skips main entirely, goes to the WAP branch that Iceberg creates automatically. Last step, if everything checks out, publish into main using fast forward. If not, drop the branch. Simple and safe. Branching and tagging turn your tables into version-controlled assets. The same discipline we've applied to code for decades, now for data. Test changes safely, validate before publishing, deploy without crossing your fingers. It's great. So go create that branch for the risky transformation you've been avoiding. Drop it if it fails, promote it if it works. Production stays clean either way.